Good day, everyone. Today, I will be discussing to you the consolidation of soil. So, consolidation of soil is very important in our topic or in our discussion in foundation design, since it affects the design of our foundation. So, in this topic, we will be discussing about what is consolidation, its principle, and we will discuss later, or we will have a sample problem about consolidation. So application of stress in soil causes compression in soil. Compression in soil can be due to reorientation of particles, deformation of particles, and expulsion of water. So what are particles? Particles are the composition of a soil. It's either a sand grain, aggregates, or organic materials. So when we say reorientation of particles, this a composition rearranges. Uh, some may enter the voids from its adjacent particles. So when that happens, there is a compression of soil. And when we say deformation of particles, some of the particles which are organic, some of it has a properties of elastic and plastic. So they deform when stress is applied to it. So there is a compression when there is a deformation of particles. And the third, expulsion of water. When a clay material is saturated or it has a water content, once the stress is applied to the soil, the water is being expelled. And when the expulsion of water occurs, there is a compression of soil. Soil settlement is divided into two categories. First is the elastic settlement, caused by elastic deformation of dry, moist, and saturated soil without change in moisture content. And the second is the consolidation settlement. It is a result of volume change in saturated cohesive soil because of expulsion of water that occupies the void spaces. The consolidation is time dependent. So in elastic settlement, the soil is being deformed elastically. So when we say elastic, once the stress is applied on the soil, there is deformation, but it returned to its original form because it is elastic. Ang opposite na kadya is plastic. So once we say plastic, when something or an object is deformed plastically, so there is no return, it does not return to its original shape. So in elastic, when an object is subjected to a stress, it deforms but it returns to its original shape. So elastic settlement happens to a soil either dry, moist, and saturated, but it does not change the moisture content of the soil. So in consolidation settlement, it is a result of volume change in saturated cohesive soil because of expulsion of water that occupies the void. Okay, so when we say consolidation settlement, the volume of a soil changes because of expulsion of water. So once the water that occupies the void is being expelled, then the soil uh, settle and it changes its volume. Okay. For the fundamentals of consolidation, let's consider a cylinder filled with saturated clay soil. In figure A, let's assume that the whole figure is a cylinder and the yellow color contained inside a cylinder is assumed as a clayey soil. And the orange at the top will be a plate compressing the soil. with a valve represented by a gray figure at the top of a plate. Okay, and as you can see in figure A, P is equals to 0. P will be the load applied to the plate, and the valve is closed. So the pore water pressure represented by delta gamma is equals to 0. So there is no force applied and the valve is closed. But in figure B, P has a value, the value of X, and still the valve is closed. Uh, but the pore water pressure will be equal to P over A. And A is a cross-sectional area of a cylinder. And the delta gamma prime is equals to 0. And again, delta gamma prime is a effective or increase in effective stress. Okay. And the delta gamma is the total stress in soil. So in this case, delta gamma or the total stress in soil is equals to a pore water pressure alone. And in figure C, as you can see, P has the value of X, and the valve is already open. So the water is being expelled at the valve, and at the height of HW. The water has the height of HW. And the effective or the increase in effective stress in soil is equals to the density of water times the height of the water. And the total stress is equals to the pore water pressure plus the increase in effective stress. And the pore water pressure is less than the P over A. And in figure D, the water is already expelled. So there is no water content left in the clay soil. So in this case, the pore water pressure is equals to 0. And the effective stress or the increase in effective stress is equals to the density of water times height. And in this case, the total stress is equals to the effective stress because the water has already been expelled. So, as I've explained kaina, ang delta gamma is the total stress, and the delta gamma prime is the increase in effective stress, and the delta U is the increase in pore water pressure, and P is at the applied load. Okay. So in this graph, it shows the time deformation plot during consolidation. So when a load is applied, since mentioned ko kaina nga ang consolidation is time dependent. So in this graph, the vertical uh, part of the graph is the deformation, and the horizontal will be the time in log scale. So as the soil deforms along with time, the first stage will be the stage 1 and stage 2 and followed by stage 3. That will be explained in the next slides. Stage 1 is the initial compression caused by preloading. So these are the compression caused before pa tana kargahan or gin-applyan kang stress. So kung nakita nyo sa graph, slow ang ana nga deformation for a longer time. And stage 2 will be the primary consolidation. When we say primary consolidation, these are uh, deformed during pore water pressure is converted to effective stress by expulsion. So it happens during the expulsion of water in a soil. Okay? So the deformation, kung nakita niyo sa graph, is very drastic ang pagnaba na? It's because it's drastic with a short period of time because the water is being expelled. Okay? And for the secondary consolidation, okay, again sa stage 2, ang end, ang pinakapunta kang primary consolidation, kung nakita ninyo, nag-amat-amat rin tana kang naba ang pag-deform. It's because sa pinakakatapusan ka primary consolidation, ang tubig is completely expelled. That will be the end of the primary consolidation. And for the stage 3, the secondary consolidation, it occurs when pore pressure is dissipated, and deformation takes place because of plastic adjustment of soil fabric. Okay, again, when we say plastic, there is no return in its original form. And this consolidation, the secondary consolidation, happens when the fabric of the soil adjusts. But as you can see sa graph, gamay-gamay lang gid ang deformation nga kakatabo for a long period of time because the secondary consolidation is happening very slowly due to adjustment na lang gid kang soil fabric. The difference between the primary consolidation and the secondary consolidation, again, sa primary consolidation, naga-expel ang water sa soil. Thus, the water is being expelled. That's why ang consolidation is dasig. It's very drastic nga nagakatabo for a short period of time. And the end of the primary consolidation is wala rin ti tubig sa soil. Okay. Normal consolidated and over consolidated clays. What are this? When we say normally consolidated clay, this is a present effective overburden pressure. Okay. Present effective overburden pressure is the maximum pressure to which the soil has been subjected and in the past. For the over-consolidated, the present effective overburden pressure is less than that of which the soil has been experienced in the past. So, experience in the past. When we say experience in the past, the soil is being subjected before, kauna, sa pressure. So, ang present, ang gina-apply ng overburden pressure. If you say overburden, ang gina-apply mga pressure sa soil. So, in our case, that will be the structure, that will be the foundation. So, if you apply the overburden pressure on the soil, if we say normally consolidated, ang overburden pressure nga gin-apply natin, amuran ra ang maximum mismo nga pressure nga na-experience man kang soil. With consideration, halin pa kauna. But in over-consolidated, the present effective overburden pressure is less than that of which the soil has been experienced in the past. That means nga kauna, mas bahal ang na-experience na nga stress kumparar sa ginbutang mo ka dyan nga pressure ka na. And the pre-consolidated pressure represented by gamma prime C is the max effective past pressure. So remember that because in our problem, we'll be using these terms to identify what is the required, what will be the formula to be used in the problem. Okay, settlement from primary consolidation. As you can see sa ating figure, the soil, there is a settlement from primary consolidation that is SP and has a total height of equivalent to H. But this is equivalent to a soil na gin-separate mo sa anang void. Solid soil and separated by the void. the height will be represented as HV, and the height of the solid will be represented as HS. So this figure, at the left and the right, are equal. So for the first formula, as shown in the figure, uh, the formula 1, the settlement from primary consolidation is equals to H delta E over 1 plus E is of O, or that where SP is the primary consolidation settlement and delta E is the change in void ratio, and is of O is the soil void ratio. Okay, so this formula, we will be using this sa example later. And again, delta E, or delta E is equals to SP over HS. Makita mo man tana sa figure. So settlement from primary consolidation with consideration for normal consolidated clays. Paano mo ba ma-consider na normal consolidated clays tana? So there is a condition. So when delta gamma, or the total stress, is equals to the total increase in effective stress, that is the condition. Okay, before we proceed to our formula, let's define first the symbols that we will be using, or the variables. Okay, the gamma primes of O is the average effective stress in a mid-height of clay soil. And the delta gamma prime will be the total effective stress in clay soil, and H will be the total height of clay. The CC is the compression index. So there are two formulas to compute a compression index with two conditions also. First is for the undisturbed clay. CC will be computed as 0.009 times liquid limit minus 10. And for the remodeled clay, meaning gin-extract mo na siya, gin-mold mo siya, that will be the remolded clay. CC is equals to 0.007 times liquid limit minus 10. So that will be, as shown sa left, this will be the formula if the soil will be considered as normally consolidated clay. For over-consolidated clay, there is two conditions. The first will be the average effective stress in a mid-height of clay soil plus the total effective stress in clay soil is less than or equal to the pre-consolidated stress. Okay. Before we proceed to our formula, first, I must discuss the symbols and the variables that we're going to use. Okay. For the gamma primes of O, it will be the average effective stress in a mid-height of a clay. Okay, remember that? Average effective stress in a mid-height of a clay. So for gamma prime, it will be the total effective stress in clay soil, and the H will be the total height of clay, and CS will be the swell index. Okay, so in the formula, SP is equals to CSH over 1 plus E sub O log uh, gamma 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 primes of O plus delta gamma prime over gamma prime of O. Okay, that will be considered as 1.4, formula 1.4. Okay, so for the second condition of over-consolidated clay, the condition will be the average effective stress in mid-height of a clay soil plus, okay, correction ha, ang delta gamma prime, wala dyan tanati prime, okay, but it will be defined as the total stress. that will be a total stress. So, wala siya prime. Okay? Will be greater than the pre-consolidated stress. Okay? So again, the same man tana sa ang mga symbols na ginagamit natin is the same man sa previous ng formula. But here, on the formula, sa correct ko kaina, okay, wala siya correction. The formula is correct, okay? And that will be the formula 1.5. Okay. Let's discuss an example. So I'm sure nga some of you is familiar with this because pa-assignment na kanunja. So the example will be a soil profile is shown below. If a uniformly distributed load delta gamma is applied at the ground surface, what will be the settlement of the clay layer caused by primary consolidation? We are given that a pre-consolidated stress for the clay is 125 kilonewton meters squared and CS is 1 over 6 cc. So this figure below will be the condition of our soil. The load is applied with a value of 75 kilonewton over meter squared. That is uniformly distributed load. So the first layer of the soil strata will be the sand, but it's dry. So from the natural ground level, going down 2 meters will be sand, but it's dry with a unit weight of 16 kilonewton meter squared. And the second layer of the strata will be also the sand, but the depth will be 5 meters. And it's already saturated because it uh, it it is located below the groundwater level. So the unit weight of the sand will be the saturated unit weight, the 18 kilonewton meters squared. And below the sand will be our clay. The 3 meters below the sand is a clay. So it is already saturated. The unit weight will be na 19 kilonewton meters squared with a void ratio with the value of 0.75 and the liquid limit is 40. In order to solve the problem, we must first identify the given. So the pre-consolidated stress is given 125 kilonewton meters squared, and the applied load or the total stress is equal to 75 kilonewton meters squared. So the problem here is that we don't know what formula we are going to use. In our previous discussion, there are three formulas for normally consolidated and over consolidated clay. But in over consolidated clay, there are two conditions. But since pre-consolidated stress is given, then it is safe to assume that it is a over consolidated. But we must first check what condition we are going to use because there is two conditions for over consolidated clay. But in order to check the condition, we must first solve for the average effective stress. And I know nga natun-an nyo rin dyan ang formula nga dyan sa inyong previous nga course. That is the mechanics, the soil mechanics. So here, I will just discuss it again to you and explain what will be the content of the formula. So for the average effective stress, uh, in our condition in the figure, so there is a height of the sand, the dry sand times the unit weight of dry sand plus the height of the saturated sand times the unit weight of saturated sand less than the unit weight of water plus 3 over 2 or the mid height or the mid height of the clay. So it is from the top of the clay to the middle part of the clay times the saturated unit weight of clay minus unit weight of water. So you could compute it directly sa inyong balay para mapraktisan ninyo. But the unit weight of dry sand will be 16 kilonewton meter cube. And the unit weight of saturated sand will be the 18 kilonewton meter cube. And the unit weight of water will be 9.81 kilonewton meter cube. And the unit weight of saturated clay will be 19 kilonewton meter cube less than 9.81. So by computing it, you could check it sa inyong calculator, but in this case, sa computation natin is 86.74 kilonewton meter squared ang average effective stress. Okay? Due to primary consolidation, okay, gin-highlight ko dyan kaina nga ang katapusan kang consolidation, primary consolidation is ang tubig is fully expelled. So there is no water in the clay. So when there is no water, there is no pore water pressure. So the pore water pressure is equals to 0. And the total stress is equals to the increase or the total effective stress plus the pore water pressure. But since pore water pressure natin is 0, then the total stress will be the total effective stress. So the conditions in overconsolidated clay will be the effective stress plus the the total the average effective stress plus the total effective stress. Okay, again the total average effective stress plus the total uh, effective stress less than or equal to the pre-consolidated stress. That is the first condition. So since nga ang total stress plus total stress is equals to the total effective stress. So meaning ang aton nga ano nga dyan, aton nga total effective stress is equivalent man sa 75. So by adding the total the average effective stress plus the total effective stress, ang answer na is 161.74. Okay? So, it is greater than pre-consolidated stress. So, wala siya nakapasar sa first condition kang overconsolidated clay. So, let us check sa second nga condition in which ang average effective stress plus the total stress siya which is 75 is greater than the pre-consolidated stress. Tama ba? Okay. Since nga pre-consolidated stress is 125 and ang total kang aton nga average stress or ang okay, nagasala rin ako. Ang total kang aton nga average effective stress plus total stress is 161.74. Bakal gyapon ta na sa 125, then we will be considering the second condition of overconsolidated clay. So the formula will be this, okay? Since na given naman ang height, ang h will be 3 ang height nga dyan is the height of the clay. Okay, we'll be considering the clay because we are studying the consolidation or the settlement in clay. Okay, and CC, since wala the value ang CC, we could compute it by 0.009 times liquid limit minus 10 because the clay is undisturbed. And the CS, the swell index, can be computed as 1 over 6 CC is equals to 0.045. Okay? So by substituting the data given and the data computed to the formula, then we could have the answer 62.3 mm. Actually covered siya, but sa isan ko kanin yung PowerPoint, you could just simply remove the covering, okay? So that will be the answer, 62.3 mm. Okay. So in this discussion, our focus is to compute the settlement from primary consolidation. But for our next topic, we will be discussing about the settlement from primary consolidation with consideration of the isolated footing or our footing. So in our next discussion, we will be discussing about how we could compute the average effective stress under the footing. So maybe I will discuss or I will be presenting it to you in our next schedule. But today, I will just stop here sa pag-compute ka settlement from primary consolidation. So if you have questions in our topic, you could contact me personally, of course, sa ating group chat or on my messenger. Or mas better na if you could comment it under sa Facebook page natin, sa group page natin. Para nga ang inyong mga questions, makita man kag inyong mga classmates kag kung ano ang sabat natin, makita mananda. So that will be a healthy discussion kung dyan natin i-discuss sa comment section. Okay? Kay kung personal nyo lang ipamangkot, I could answer you, but to those nga have the same question kaninyo, but without guts para mag-raise up kanaken, at least makita nanda kag makaruhan sila sa mga questions. Okay? So that will be the end of my discussion, and expect na lang ang sunod natin na discussion with the topic settlement from primary consolidation with consideration sa footing. Okay, so this will be the end of my discussion. So I hope you will study this problem and practice this problem kasi I will give this sa atin nga midterm exam. I will have this kind of problem on our midterms exam. Okay? So, God bless and goodbye kaninyong tanan. Thank you, Gid, sa pagpamati. So, the value for the primary consolidation